Boom, there we go. All right, an even function has symmetry about the y-axis, and I'll make sure to use the right color. Y-axis. An odd function has symmetry about the origin. All right, let's take a look. This first function on the left, okay? What does symmetry mean? Thank you. Describe it to me in layman's terms, though. It's the same on both sides, meaning if I was to fold along that line, it should land on top of itself, correct? So looking at this, here's the y-axis. If I was to fold along that red line, would it fall on itself? Yes, so that means that this is an even function. Okay, on the second one, okay, is it symmetrical about the y-axis? No, I can't fold and land on top of itself. So the next thing we got to try is the origin. So what I'm going to do is I'm going to take this point and this point, which are max and mins, which we'll talk about in a second. Okay, and this point is at negative 1 comma 3. This point is at 1 comma negative 3. Okay, notice that their x and y are the exact same numbers, but their signs are different. Okay, if I connect those, what point do I go through? The origin, or 0, 0. If that happens, then you have an odd function. And you can do it with any points as long as they're not intercepts. So like here, if I chose this negative 2 comma negative 1, and then 2 comma 1, same thing. If I connect them, I go through the origin. Number 3, definitely not over the y-axis. I think that's pretty obvious. Is it through the origin? No. Okay, so therefore it is neither or neither, whatever your heart desires. Everybody says it a little differently. And then the last one, what do you think it is? It goes through the origin. If you take this point, which is the max minimum, and this point, which is the maximum, and connect them, go through the origin. If you take this point and connect them, you also go through the origin, so it's odd. All right, a function is even if f of negative x comes out as f of x. I'll explain what that means in a second. It's odd if it comes out as negative f of x. Okay. So here's how you approach it. Determine if a function is even or odd. You're going to take negative x and substitute in for x into your function. If you do that and you get the exact same function that you originally had, then it is an even function. If you do it and get the exact opposite of what you had, then you have an odd function. And if you do it and get neither the same nor opposite, then you have neither. Very good. So, let's take a look at these three. So the first one says f of x is x to the fourth plus x to the third. If I replace x with negative x, so it's going to be negative x to the fourth plus negative x to the third. Well, if I take negative x and I put it to the fourth power, what do I get? Positive x. So it's going to be x to the fourth. And if I take negative x and put it to the third power, what do I get? Negative x. So it's going to be negative x to the third. So now let's take this and compare it to our original function. Is it the exact same? No. Okay, that means it's not even then. Is every sign the exact opposite? No, so that means it's not odd. So because you said no to both, it is neither. Okay, what one? Okay, same thing. We're going to plug in negative x, so it's going to be negative x to the sixth plus 1, which comes out as x to the sixth plus 1. So compare it to its original, or is it the exact same? Yes, so that means it is even. Okay, and then last but not least, f of x equals 6x to the fifth. So I'm going to change it. So it's going to be 6 times negative x to the fifth minus negative x to the third. That's going to be negative 6x to the fifth minus negative x to the third. And then what's going to happen here? Double negative. Changes it to a positive. So it's negative 6x to the fifth plus x to the third. Exact same? No. Complete opposite? Yes. So therefore it's odd. Okay. Now, we're going to take a moment. I want you to look at these functions here and your answers over here and see if you find the pattern. So, if you look at this last one here, both exponents are odd. I have an odd function. If you look here at the 6, that's an even, so I have an even function. What's the exponent of the 1? No, it's 0 because there's no x. Okay? And then up here I have a mix of even and odd, that's why it's neither. Little shortcut. Okay? Can odd functions have a constant at the end of them? Why not? No matter what you do to the function, if I have a constant at the end of an odd function, it will not be odd anymore because the sign of that constant will never change. Okay, so only even functions can have a constant at the end of them. All right? Everybody good with that so far? All right. Don't hate me. But if you do, it's okay. We're about to have 10,000 vocab words. I wouldn't blame you if you just wanted to type them in here and then fill it in later. Because there's a lot. Okay? We already know domain. Domain is representing our x values. We already know our range. That's representing our y values. We've talked about that, so that is not new. That's a terrible name. My sister is having a child. She told me what the name is. A-R-I-A. Is that like Aria? Aria? Yeah. Okay. Well, it is what it is. Zeros, solutions, roots. All the same thing. They are your x-intercepts. I should probably go cut that part out of the video. That'd be weird. Your parents are watching and I just start randomly talking about that. Should I do that later? Increasing intervals. Okay? Increasing intervals means that the graph rises from left to right. Okay? The graph rises from left to right. Well, I'm going to talk about this in a few minutes, so don't stress about that phrase. I'll explain what that means in a few minutes. Decreasing interval means that the graph falls from left to right. Constant interval means that you have a horizontal line. Everybody here? Oh, somebody's not here. Who's missing? Chikai. Everybody else is here. I forgot to take attendance first and second period. Oh well. I'll wing it. Okay. Intercepts are the points that the graph crosses the x or touches the x-axis. They're always written as blank, comma 0. You should know that. The y-intercept is where you touch the y-axis. So those are 0, comma blank, whatever your y-axis is or y-intercept is. Okay. Negative intervals. Negative intervals are when your y value is less than 0, meaning when is the graph below the x-axis? Your positive intervals are opposite. They are when the graph is above the x-axis. Okay, for the next part, I'm just going to talk. There's no writing. So, extremas are points in which the function is at its largest or smallest peak, but there are two types. There are relative extrema and absolute extrema. Relative extrema means that it is only the highest point compared to the points around it. Absolute means it's the absolute highest or lowest you're ever going to reach. So let's go back to slide 1 for a second and take a look. Does everybody see on this graph right here, -1, 3, and 1, -3? Those are considered to be relative max and mins. Why? Because there are still points on this graph that are higher than them, just not in the points that they are around. So this is a maximum in this area. This is a minimum in this area. So that's why they are relative. But if you look, there are still points that are smaller than it later on, or higher than it. So that's why it's a relative min or max. Whereas if I go to this one down here, these points that I have on this graph are considered to be absolute max or mins. Why? They are the highest this graph ever gets to, or the lowest this graph ever gets to. Does that make sense? Okay, good, because I'm going to quiz you in a second. Not literally quiz you, like mentally quiz you. All right, end behavior. Oh, we're almost done. I promise. Here's the phrase. Okay? You saw it earlier in increasing and decreasing. It means this. As x approaches negative infinity, y approaches blank. And all you have to do is fill out the blank. Okay, so that's the left side. You look at the leftmost point of the graph, figure out what's happening. For the right end behavior, it's the same exact phrase except for one minor detail. It's as x approaches positive infinity, y approaches blank. Now, do not underestimate the power of this phrase, because it's your first glimpse of what calculus will look like. This phrase right here is your first introduction to a limit, meaning that you are limiting the graph in one way, shape, or form, which is what you'll learn in calculus when you get there. You might even touch on it in pre-calc. It's been a while since I've been in school, so I can't remember if it was in pre-calc or not. All right? That's the phrase that you will always write down for end behavior. Everybody good with that? Okay. Now, I've already graphed this in Desmos. Here's what it looks like. You have a point at -2, 0, 2, 0, 0, 4, -1.225, 6.25, so like somewhere around here. And then opposite, 1.225, 6.25. And then it goes like this. I'm going to put up the Desmos in a second so you can look at it. But that's the gist of the graph. There it is in Desmos if you want a cleaner version. We've already talked about domain and range, so let's go ahead and quickly go over that. Does this graph cover every possible x value in the domain? It does, because it continues on and on based on my arrows here. So it's from negative infinity to infinity. For range, what's the smallest y value we have? Negative infinity. What's the largest? Yeah, it's that 6.25. Is it included? Yes, so I need a bracket. Okay. All right, max and mins. Okay, so my max and mins, I got a max and min. All right, so I have two max values. So it was negative 1.225 comma 6.25. That's this left point over there. And then you have positive 1.225 comma 6.25. Okay, that's the two top points. My question to you, I told you I'm going to quiz you, right? Are they relative or absolute? They are absolute because that is the highest that graph actually goes. Okay, you do have a minimum. It is the y-intercept, 0, 4. Is that relative or absolute? That is relative because there are smaller values in this graph, but it is the minimum on the points around it. Okay, we already talked about 0, 4 is your y-intercept. That's the point that we cross the y-axis. How many x-intercepts do you have? 2, negative 2, 0, and then also 2, 0. They are also called solutions, zeros, roots, all of the same thing. Every single one of those is the exact same thing. All right. Based on looking at this graph slash looking at the equation, what do you expect this to be? Even. Okay? You are right. It is even. I can look at it from the graph and see that it's clearly reflecting over the y-axis. So my symmetry is clearly the y-axis. Okay? We see that. But if I also look at the equation and look at my little trick that I showed you, where are all the exponents? Even. So that's how we can tell it there too. If you don't know, you don't want to guess, you can always plug in negative x into the function and see what happens. So negative x to the fourth comes out as positive, so it's negative x to the fourth. Negative x squared comes out as positive, so it's still plus 3x squared. And then plus 4. And notice you get the exact same thing you started with. So that's why it's even. All right. Positive intervals. This is where it gets a little bit confusing. Okay? I warned you ahead of time that this was not going to be easy. It's a lot of information that I'm throwing at you today. A lot. Okay? Positive intervals. Positive intervals is just telling me when is the graph above the x-axis. Well, if I look at this, I am above the x-axis from this point to this point. Correct? This is why it's confusing, because you're talking about y values, right? But when you're describing it, you're going to describe it in like x values. So I am in the positive interval. I'm above the x-axis from the leftmost x value, which is negative 2, to the rightmost, which is positive 2. So from negative 2 to 2, you're telling me I'm above the x-axis. That's what it says. Would I put brackets or parentheses around those numbers? Why? Yeah, negative 2 and 2 are 0. 0 is nothing. It's not positive, it's not negative. It's 0. It's neutral. It's Switzerland. Whatever you want to call it. Okay? That won't ever change. So if you're starting to look at this and what we're doing, right? What's the only time you might see a bracket occur if you're looking at all this? Domain and range. Typically, positive, negative intervals, increasing, decreasing intervals don't have brackets. Okay, so now for our negative intervals. I have two pieces that are in the negative. I have this piece over here and this piece over here. Okay, the first piece is from negative infinity to that negative 2. And then the second piece is from 2 and then continues to infinity. When you have two pieces, you have to put this guy in the middle called a U in union with, and again, we'll explain that more and more as we go along. Okay? But what that's basically saying is, in between there, something else is happening. Well, we know what is happening because what is happening is our positive interval. Okay? And then last but not least, end behavior. We have an infamous phrase that we are talking about. As x approaches negative infinity, y approaches blank. As x approaches positive infinity, y approaches blank. Okay. So, when it says as x approaches negative infinity, what you're talking about on the graph, you're talking about this side. So this is x approaching negative infinity over here. Look at your leftmost point, which is this guy right here. What is it? It's an arrow. Which way is the arrow pointing? It's down. So where's your y going to? Negative infinity. Whereas on the other side, x is approaching positive infinity, this guy over here, meaning you're looking at that arrow, and again, which way is it pointed? Down, so it's also going to negative infinity. Whew. All right, so for our last example, it's x cubed minus 9x, so I'm going to go ahead and graph that on my Desmos here. Zoom it out a little bit. Okay, so we have a couple points here. One at 0, negative 3. Negative 3, 0, I should say. 0, 0, 3, 0, 0, negative 10. I'm just going to park it down here. At that, let's see where that point's at. That's a little bit above and below. So it's 1.7, negative 10.4. You have another one up here, same thing. Negative 1.7, positive 10.4. So this is what it looks like. Once it's done. All right. Go back to our there. Okay. So our domain, because it goes in both directions, it would be negative infinity, comma infinity. Our range would be also negative infinity to infinity, because it goes in both directions. Okay, you have maxes and mins. You have a max and you have a min. Both of them are going to be relative because there are points that go past it. So our maxes will be at negative 1.7, comma 10.4. And our min would be at positive 1.7, negative 10.4. Okay, you have a few intercepts. You have x-intercepts and y-intercepts. Okay, so your x-intercepts would be negative 3, comma 0, 0, comma 0, and 3, comma 0, and then you have y-intercept is also 0, 0. So the y-intercept special, it's a little bit of both. Okay. So positive intervals start here and stop here. Okay, so that's from negative 3 to 0. Okay, and then they pick up here and go to, they pick up here and go on forever. So that would be from 3 to infinity. And again, that's in union with, which we talked about the last one, because there's two things. Okay, same thing for your negative intervals. Your negative intervals start on into negative infinity and stop here. So that's still negative 3. But then they pick back up from here to here, which is from 0 to 3. Again, in union with. Okay. We're going to replace our negative x into our function. So it's going to be negative x to the third minus 9 times negative x. So you're going to have negative x to the third plus 9x. So all of our signs are opposite, which means this is odd. Our symmetry is over the origin.